Okay, so we've got a real simple situation. We've got two balls, this 2 kilogram ball going 1.8 meters per second, heading towards a 0.7 kilogram one, which is at rest, that's stationary. And then after the collision, the 2 kilogram one is going back the other way at 1 meter per second. And the question is, what's happened to the 0.7 kilogram one? Is the question. So what's the first thing we're going to do here? Total mass? Total momentum before. Okay, so let's look at momentum. So we want the total momentum before. So this one has a momentum of times 2. It's mass times velocity, so 3.6 kilogram meter per second. And the momentum of this one is beforehand. Takers, what do you reckon, Ricky? What's the momentum of this one going to be? Okay, so 0.7 kilogram object with no speed. 0, exactly. So no speed, it doesn't matter how heavy it is, it's going to have no momentum. Okay, so the total momentum, just join those two together, is 3.6 kilogram meters per second in that direction. Okay, so that's the total momentum before the collision. Okay, Nick, what's the total momentum going to be after the collision? Here you go. Here you go, Nick. That compared to that. That compared to that. Just the same, isn't it? So it's going to be total afterwards is 3.6 in that direction. Yep, so that's the conservation momentum. Whatever the total momentum is before is equal to the total momentum afterwards. Okay, which one of those balls can we work out the afterwards momentum from easily? Yep, so we know the mass and the speed for this one. So for this one, it's 2 times 1 is 2, going that way. So the question is, what is the momentum of this one? Okay, so we've got Nick suggesting 1.6. Any takers, anything different? So where's your 1.6 come? Which direction, Nick? And where's...
it'll be 1.6 times 0.7.
No, I just want the momentum. So the times in by 0.7 will give you, starts playing with the velocity again. 8. Where's 8 coming from, Sam? No, time out. Too hard. You're making it far too hard for yourself. Where did we get this 0.4 from? We said, yeah, the difference. So that one plus that one had to add up to that one, didn't it? Okay, so what's missing here? 1.6? Which direction do you want me to put the 1.6 in? That way. This way? Yeah, that way. So if I have 1.6 going the other way. So I have 1.6 going this way. Yep. 1.6 plus 2 is 3.6 that way. Yep. I want 3.6 that way. So okay, so you put your 1.6 this way. You have 1.6 that way and 2 that way gives me 0.4 that way. 5.6. Okay, so if we make this 5.6 that way, then 5.6 that way, take away 2 because it's going the other way, gives me 3.6 that way. Okay, and hopefully now we can do P equals mv, so V is P divided by M, is 5.6 divided by 0.7 equals 8. Okay, but that was the answer to the velocity, Sam, not the well done. not the momentum. So you have to go through that momentum stage in the middle. Yeah. So the direction really matters. Yeah. So you do have to think about directions when you're thinking about how these things work. Okay. So here's an example where you've got two things that don't stick together, and you can work out what's going on with the velocities afterwards.